I use Redux. So why would we want to have Redux? Anyone here using Redux today? No. So few new, but you use it? Use it daily in your production? So is it big projects or small?
Mainly small. There's one that is a bit big now, but mainly small.
Okay, cool. So when we do front end today, the simple things, they tend to be bigger and bigger. The single page applications become quite complex when we build them today. And which means we have information in a lot of components, services, and it's really gets hard to keep track or do changes in your applications when your application grows. And for that, Redux is one way to make it simpler. And simpler doesn't mean it's easier, but at least your life is going to be easier because you know how you can handle your state in your application and you get better overview of your code. So what's Redux? Redux is a predictable state container for JavaScript application. What does that mean? That means that it's one place where you have your state of your application and it's predictable. And with that predictability, that means that when you apply one action on a specific state, you will always get the same result. So if you put in the same state and apply the same action, you will always get the same state out from that. That's the predictability of Redux. And that's really important thing when you have front-end applications where you want to test, you want the predictability to know what should happen if I do this. So how do you do with Redux how does Redux handle this state? Well, it uses actions and reducers to modify this state. That means that you always emit an action, apply it on a state, and through a reducer, you get a new state. Something like this. A reducer is gets input, one action, and the current state of the application does something with that state, depending on the action, and returns a new state, which then is put back, and you can apply it and so on. So it's very simple pattern when you work with this. So what's a state? Application state. When we saw that dashboard in the beginning, that's a complex application. And the state of that application is all the different values, configurations, who is logged in, and so on. Is that at a specific moment? That's the state of that application. And that state you store in something called the store in Redux. And states are simple objects, JavaScript objects. So they are JSON serializable. They don't contain any functions on. They're simple JavaScript objects. And when you define your application state, you define an interface and what should it have. Here I have a very simple application state with an attribute called user, which is of type string, which can contain the name of the logged in user. It can be empty string or null or a name of the user that's logged in. That's the state of your application when you handle in this case. So this is the basic thing.
Sorry, can it be null when you set it to have to string?
Well, yeah, null can, I think, I don't know, I'm not sure. I think in the TypeScript allows that. I'm not sure. But that's, it shouldn't be null if it's a string, but and when you define your application state, you also have to think about your application, what's really the important things and how you share the data and so on. Because when you, I don't know how you, but when I build before Redux, I tend to have data in, some data is in one service and some data is in another service. And then when I need that data, combine that data on a component, I have to inject both, get the data from them, and do something in the component. And then I want to change the data. I change it in this service. But then I have two other components using this data, and they don't know about the change. So in my application, it says logged in user Sasha, but I'm logged out, let's say. So you get this inconsistency with having data in all these different places. But Redux, you get the data in one place, in the store. The store contains the application state, and you know this is the place where you have all the data, or should have. So all the components can fetch the data from here, and you assume this is the truth of your application. So you shouldn't have any changes or any other data around in your components or services that's not reflected here. What's important to remember about the state is it's read-only. And by read-only, it means that when a reducer makes changes to the state, or when they apply the changes that an action has been emitted, it creates a copy of the current state, applies the changes, and returns a copy of the new of the old state with the applied changes, which is the new state. Which means that any references to the old state still keep the old data. And for that, it's the important thing here is that when you use observers, which I will show you later, when you observe the store and you observe the changes, all the components who need to know about this new state, they will be notified through the observers. Here's a new state with the data that you are observing. Please use this data instead of the old one. And this way you always know that the real state is in the store and it's pushed to the new one. And you never have to have this problem that you changed data, especially if you have a like object with arrays and so on, and you change something, but it didn't propagate to all the other places where you reference this object because Angular didn't get notifications, so you don't see it. It was no changes and so on. And you don't know who changed it. Here, you always know that you have one place to turn for the state. And that's why you handle the state as read-only. You never change it, the existing state. And the one thing that's important about useful for this is something called time travel, which I will show you later, for when you're debugging or want to go back to see what was the value of the application state when back in time. That's why I said this application state is for specific time, so you can go see exactly what's happened in your application for over a time. So to change a state, you have to emit an action. So what's an action? Action is just information about something that has happened or should happen, or is happening. And how do you implement that? So this is a simple action. It's a type. I call it login success. That means I have logged in. And payload, some data for the action, my name. So this is the information about the event that has happened. I have logged in. So this is like an event that would be emitted, an action that's emitted after you have got the response from your backend that you are logged in with this user, then you emit this action. How you emit, I will show you later. But this is the action that's created and sent off to the store. And when the action is emitted and telling what's happened, it's the job of the reducer to take that action information and do something with it. And the reducer is a pure function. How many know here what's a pure function? Yeah, so a pure function is a function with no side effects. And what does mean? That means is that the reducer, like we saw in the previous slides, takes an action, definition of some event with some data and the current state, and does something with that action, that data, and emits a new state. And no side effects, it means the reducer will never call something else. No async calls or no other call. It will do what it needs to do with the state locally. So there is nothing else that's affected of this call to the reducer. That's what's called pure function.
And it has to be idempotent, the same input will always be the same.
Exactly. So if you send in the same state and the same action with the same payload data, it should always return the exactly same state. And when you grasp that, after a while, it becomes like your application becomes so simple. It doesn't matter how complex the application state is and so on. You always know that this part of the application state is managed by this reducer, and it becomes really, really readable, like I will show you later. Here we have a simple reducer. Anyone know what it does? Nothing. It takes a state and an action and returns the same state. So it doesn't do nothing. So it just returns. And this is like the default of a reducer. A reducer must return a state. It can never return something else. It always has to return a state. So you always have the default, like if there is an action submitted in here that's not handled by a reducer, it should return the same state out again. And what you do when you build your application, it becomes bigger and bigger. You divide your reducers in smaller reducers instead of having one reducer for your whole application. But all the actions are sent to all the reducers. So all reducers can handle all actions if they want, but usually what you do is you divide them. So this reducer handles only login, like session actions, and this one handles my account actions and so on. So your code becomes readable. And so when there is an action submitted to those reducers which don't handle that action, they will just return the same state back. They said they didn't change it. And here we have a reducer who does something, takes a state and an action as input. It checks the type, and if it's a login success, like we saw in the previous, what it does, it makes a copy of this state and applies this, the data, and stores it as user on the state. And if you remember, our application state definition was user string in the beginning. And here would be my name, Sasha, with this login success stored in the application state. And then it's returned. And we have returned a copy of the old state applied with the new data. So we never change the old state. Any questions?
When you do error handling here,
Here you
the action payload actually is an integer instead of a string. Should that have been caught earlier, or is it here that you...
that should be caught in your that should be caught earlier. And if you do it correctly, you will TypeScript should catch that if you do it with TypeScript, because if you have any action or anything that's sending integer, it should warn you about the typing.
I mean, that's an example that works on this code, but in general, should there never be any error handling
No,
in the reducer?
I never do error handling here. If I do any error handling, I do it before.
What actually happens if you change the state, like the original state?
If you change it, then you get problems sooner or later. Because you will not know why it was changed. So you will get problems sooner or later.
So it's not going to notify, oops, you're modifying the original state.
Now it will.
I think Redux internally will actually check if the state has changed, and it won't admit an event if nothing has changed. If you just mutated the previous state, it won't know that anything's changed to know if the event will be.
Yeah, and the thing with making, like, in my, like, I'm an old developer, I feel very old, but in my head, this was like really, really expensive thing, especially if you have a big state. But changing, like making copies of objects in front end, it's like it's just one user working there, and it's really, really quick. It's really optimized the implementation in JavaScript to do that. So you don't get any performance issues with this unless you have like 500k items in your array or whatever. Then you start copying that, then you can get some issues there. But you don't get any performance there. So it is really fast, and you remove so much problems by wondering why did this change, or why didn't this change propagate here, and so on. You just know, okay, I want to change this state to with this value. You send it off, and any component who wants to know about the change has to subscribe to the store.
You don't have to return the state with default?
Yes.
You have to return it.
Yeah. Yeah, I think so. Yep. This is written in the presentation, so it's not copied from the real code. So yeah, you should return it there. And okay, Angular and Redux. There are a few implementations. If you Google Angular and Redux, you will get probably these two on the top hits. This one, Angular Redux store, was called ng2 Redux, renamed now to this one, since Angular 2 is also, the 2 version is gone. And this one has still the name. I have been using ng2 Redux, So I will use that as an example for the code that I will show you today.
This for Angular
2. This one you have ng redux 2 for Angular 1. So this one has been around. This one I don't know if there is any versions for Angular 1. And there is one syntax here that I like a lot. And I don't know if it was that one which made me use that one, but after I started using it, I never took the time to learn some other implementation. But they are good, both of them. So if we want to create a reducer that does a little bit more, or does something at least, here we have a reducer counter reducer with 2 actions, increment and decrease. We have an initial state, which is called a number 0, and we set it as default because when you start your application, then you don't have any state. You have to initiate it with a state, and reducer always has to return some state. So what it does, if you emit an action increment, it will add 1, and if you emit action decrease, it will remove 1. And if there is any other action that you submit to this reducer, it will just pass through and return the same state. So this is a simple reducer that does something, and it only cares about these 2 actions. Following? Now we create the store. We define our application state. It has a counter and it's a number. We combine the reducers for our application state, and here we use combined reducers because we can have multiple reducers. And here we define that for counter we want to use counter reducer. So this is how you split up your reducers to handling part of your application state. So counter reducer only cares about the value in the counter. And then we create the store. We have our root reducer. So root reducer gets the state and action and then propagates it to all the other reducers that's been combined here. And with Redux and the store, you can enhance the store with enhancers like local storage, and you can apply middleware that does some magic to your store on the fly. And here we have a logger, which means that every time there is a action and state change, it should log it to console log so we can follow it. So this is a middleware that just listens there and handles everything in between. We need to define some actions. We define, so actions are injectable. So we can, the reason they are injectable is that we only need one instance of them, but also that we want to inject our, get access to our store in the action. Because the action is supposed to send, emit or dispatch the action to the store, so it can send it off to the reducers. So here we inject our store for our application state, and then if the increment action is called, what it does, it sends this simple type increment to the store, and then it's up to the store to send it to the reducers, and it's up to the reducers to do something with it. And the same is for decrease. So the action implementations are very, very simple. When you can keep them at least simple. When you get into async calls and so on, they become a little bit bigger. And in your module, you inject the ng-redux and you provide the store that you have imported from that we created before. So that's what you need to do to get the store ready in your application. We see here that we have imported the ng-redux module, and we have added our action provider here.
Could you have here different kinds of states, a lot of interfaces, and
in your application, you only have one application state, but so the counter is a state in your application state. So your application state is built of smaller states, which are handled by different reducers. But your application only has one state. You can have more, but I haven't seen any use cases for that. Here we have a component. It injects the counter actions to do something with them. And here we have this notion that I like with ng2 Redux or Angular Redux, that's called now, select, which what you do is you what's the name? When you say at before, what's the name of? What? Forgot. Yeah. At least this is the notion, and you tell I'm interested in the value of counter in my application state, and I want it to be here. And what you get here is an observable for that value. So you get an observable here, which you can subscribe to and do whatever. So every time the counter is changed, it will be pushed here as long as this component is live. So this is how you tell the component, I'm interested in this, the value of counter, and you get an observable, then you can do something. And the simplest way to use it, here we have a counter, and we subscribe to it in our HTML by piping it to async. So every time the value will change, it will be printed here. And we have two buttons that call our increment and decrease actions. Every time you press, they will just emit that action, and then it's up to the store to do something. And when the store has done something, it will check, do I have any subscribers to any data that has changed? If yes, it pushes, and then the value changes. So we can do some. So here we have our counter. No, we don't have any counter. I have one. Yeah, exactly. So here we have our counter, and if I press here, you see it counts. And Chris. So yeah. But why would we?
Can I ask you about this state?
Yeah.
We have one application state.
Yeah.
And if I have a state, one application state that changes a lot, you can swap in and out data. could I have, and if I make a change on just one sub-state of the whole state, will it cause the whole state to be loaded again? As you said, the whole state will renew itself, or will just the sub-part?
So here we only listen to the counter. So you have your application state, which now only contains counter, but it could contain the user, it can contain account or what different parts. This component will only get new data if the counter is changed. And if you remember the reducer, the state for counter reducer is just a number. So it's the value of counter in the application state. So in this reducer, the state is the value of counter that's handled here. It's not the whole application state that's sent in here and then handled.
So it's the sub-state.
It's the substate. And if you return the same, store will just see this is the same reference, I don't do anything. And if it's a new reference, then it pushes it out to others. And you can also, in your components, if you have, let's say, a user object as your state, then you can subscribe to like user, comma, name. So you only get when the name has changed. You don't have to you don't care if the password has changed or the address has changed. You just want the name. And you will only get data on that. And observables, if you haven't used it, look into it and learn, because it makes your application simpler, but much, much faster when it comes to data pushing around. But this was a simple application, and there is not so much benefit of using Redux in the counter example. Beside that, you know that you only have one place where the counter is correct, and it's the source of the truth. You don't care about any other values, or and if they are subscribed to the store, you will know they will always be updated and a correct value. So that's something that even you have a simple application, it's a big benefit when it comes to handling data. Because as soon as you have the same data in two places and you don't have it synced in a smart way, like with observables or something, then you will have the trouble that, oh, you updated something, but it didn't change everywhere. Let's say a perfect example is a spinner that you put online when every time you make an async call, you want to show the user that something is happening, he has to wait. And the call comes back, something happened, error or not, but the spinner is still there because it's watching a value that didn't change. That's something that have occurred a few times for me, at least, before Redux. But yeah, the counter example was simple. So let's see some more features and what you can do. There is an enhancer that's called Redux Local Storage, which is really beneficial for your application. So you just import it from Redux Local Storage, and when you create your store, let them kill the alarm. When you create your store, you define which parts of your application state that you want to save in your local storage. You give it a key, and every time the state changes, it will be stored in your local storage, which means that if a user reloads the browser, you can restore the exact same state the user had before. It can be navigation, it can be forms, routing, and so on. You can restore that, and the user has very good experience. And if you want to restore routing, you use Angular Redux router and configure that one. And as soon as you have configured it, it will listen on any route changes and save it to your local, save it together if you use local storage, so you can restore that. And the form makes that if a user starts typing, and even if they don't press save and reload the browser, he can keep the data that he has entered. And you can use that. I haven't used it so far, but I know from user experience that I've been typing in a lot of forms, and then something happens, and the only option I have to fix is to reload. And I know if I reload, everything will be gone. So, but these are additions to Redux, which are good to use. The local storage I use a lot. Routing sometimes, form I haven't used. But there are still simple things for Redux. What you can do with redux-observable is some really, really cool stuff. That's when the magic starts. How many here have done a call, a big call to your backend, and before the data is returned or the answer is returned, the user is gone and doing something else in your application? How many? A few. That means that there is something in your browser still listening for this call that's not returned yet, while the user is somewhere else. And when the data comes back, the call is like, okay, what should I do with this data? Still taking CPU usage and so on. And then it throws away everything because it's not needed anymore because the user does something else in your application. And redux-observable is one way to solve this, because with redux-observables, you will be able to cancel. Like if you send away async call, you can cancel it if it's not needed anymore. Netflix uses it. Let's say you start playing a movie and you say, I don't want to see this, I want to see something else. You don't want the front end to continue streaming the old movie that you selected. And what you use in redux-observable is something called epics. And what's epics is it's a stream of actions in, and it returns a stream of actions out. So let's say you say user wants to, you send emit action, this user wants to log in. And you have an epic that's listening to that action. And it says, okay, we have a user who wants to log in. So it emits login pending. That's an action. So let's start the spinner and something else. And then calls the async call. And when the async call is done, it emits login success or login failed. That's what you do there. But let's say if the user presses cancel for login, then the first call that you already have sent, you want to cancel that. And with epics and redux-observable, you will be able to do that. So here we have a simple epic that's listening for the action type ping and delays 1 second and then emits action pong. And since all this is observables, it is really easy to filter, debounce, and do all kind of different magic, especially when you have a lot of data, or you want to like wait for, you need to like have 3 different async or 2 different async calls finished before you can do something else. Then it's really easy in with observables to combine these things and still have a good performance and readable code. So here we have an async call, which listens on the type fetch user, and for every time this action is called, this action is emitted, it calls this async call with the payload that's in the action. And when the async call is done, it emits another action. Here we have functions which just emit the actions. And here we just say the user has been fetched with and the payload is the response. Are you reading it down? Yeah. And the thing with merge map is that if this action, the first action has been cancelled, it will automatically cancel the async call. So you don't need to even handle that by yourself. So there is some really nice magic inside Redux observable. But if you haven't used observables, you should really look into it, because it gives you possibilities of handling large data very fast, filtering, and also performance when it comes to pushing your data around in your application and combining data from different sources. But these parts, epics, I have just starting, I've been reading about them for a while, but haven't had time to use them, but I need them really in my application. For this, the most biggest example is to be able to cancel async calls, but the other one is to make it the code more readable, because my async actions get to become quite big. Do you have any questions on this? I see only question marks everywhere. Anyone read about epics and Redux Observable before today? Check it out. There is a great presentation here from Netflix. The Redux Observable comes from the Netflix developers. So they have released this, and they use it with React. So check that one out. I will push the slides on SlideShare and share them somewhere on my Twitter account and Meetup and so on if you want to see them. Here are some other places which I have used inspiration for this talk, but also which I have been looking at when I have been learning and using the code. So check them out.